With level 11 and systems of equations, we have reached the second to last unit that we are going to cover this year in pre-calculus. So I know that you have seen systems to some respect in college algebra and algebra 1. So this is going to be a quick unit that we should finish up within a week. So expect all four of these sections to be on your test. And so what we're going to be doing, this first section, we're going to cover substitution and elimination. Then we're going to talk about solving systems with matrices. We're going to solve systems using determinants, and we're actually going to do some solving determinants by hand. And then the last section is talking more about matrix algebra and how your calculator does these things. So there'll be a mixture of being able to use your calculator and doing stuff by hand. So make sure that you have a calculator that does matrices handy. If you don't have a graphing calculator, download matrix calculator app. So there are some calculators that are free. They might have some ads on there, but the matrix calculator app, which is both on Android Store and iOS, should work just fine. And we'll get started. So level 11.1, which is solving systems of equations by graphing, by substitution, by elimination. You have seen these since you're in Algebra 1. You should be very familiar with them. So just a couple quick vocabulary terms that your book uses that I want you to be aware of. You may have used something different in Algebra 1 or college algebra, but just a couple quick things. Linear. We all know what linear means. Linear refers to the degree of our equation. So if we have a linear two sets of linear equations, that means that the exponent is 1. So consistent or independent means that our lines intersect or have a solution. You can have a consistent solution that's the same line. We call those a dependent system. So inconsistent are systems that do not cross. So those are parallel. So inconsistent means parallel lines or no solution. So that's our no solution. And then the last one that I have here is a consistent or dependent system. And that's when you have infinitely many. So we say independent for one, we say inconsistent for no solution, and we say dependent, which is infinitely many solutions. So let's get started. Yes, there's a typo. That equal sign should be a plus sign, but solve this system of equations by graphing. So I know it's been a long time, but you guys should be able to graph these lines. The y-intercept, if we cover up the x, we get 5. So 1, 2, 3, 4, 5. If we cover up the y, the x-intercept is 5/2. So halfway between 2 and 3. Connect the dots. We could solve that and put that in slope-intercept form, but they're in standard form, so those are easy to graph. Second one, if we cover up the x, our y-intercept is 2. So 12 equals 6y equals 12, so y equals 2. So in a different color. And you can do all of this in Desmos, right? So then what is our y-intercept? Or x-intercept. Cover up the y. Negative 4x equals 12, so x equals negative 3. So 1, 2, 3. Put a dot here. And our solution is where these two lines intersect, which in this case is x equals 1 and y equals 3. And what we can do is we can write our solution as an ordered pair, 1, 3. So example 2. This should be, again, that should be a plus sign. I apologize for this. Solve the system by substitution. So in order to do substitution, we are going to plug in one of the variables for the other. It doesn't matter which equation you choose. I'm going to pick the second one and solve for y. We're going to say y equals negative 2x plus 5. Subtracting the 2 to the other side. And we're going to plug this y in here. So the negative 4x stays the same. plus 6 times negative 2x plus 5 equals 12. Now, if you notice that these are the exact same equation, we should get the exact same solution. So if we distribute, we have negative 4x plus 6 times negative 2 is negative 12x. 6 times 5 is 30 equals 12. So negative 4x, negative 12x is negative 16x. And then if I subtract 30 from both sides, we get negative 18. Let's make sure I did everything right. Yep. So x equals positive. So we're going to divide both by negative 16, which is 9 over 8, which is approximately 1. So now that we have x, in order to find y, we're going to plug in this x value in for y. So we have y equals negative 2 times 9 over 8 plus 5. Sorry, that should not be there. So negative 2 over 8 is negative 1/4, so that is negative 9/4 plus 5, which is 20 over 4. So that gives us 11/4 is y. Now you might be saying, these numbers are different than our actual answer. Well, if you went and graphed this on Desmos, you'll see that our graph by hand looks like it's x1 equals 1 and y equals 3, but the actual solution when we verify it is x equals 9/8, which is just a little more than 1, and y equals 11/4, which is just a little less than 3, which actually makes sense from our graph. So, example 3, solve the system by elimination. So you might remember elimination because we are trying to eliminate a variable. So again, you can pick what you want to get rid of. I'm going to choose to get rid of the x, so I'm going to multiply the bottom equation by 2. I'm going to rewrite both of them. 2x plus 3y equals 1. And now I have negative 2x plus 2y equals negative 6. And now I can just add these two together. When I add them together, the x's cancel. 3y plus 2y is 5y. And 1 plus a negative 6 is the negative 5. So then y equals negative 5. Once you get y, we can plug it back in for x. It doesn't matter which equation you use. I'll use the first one. So we have 2x plus 3 times negative 5 equals 1, which is negative 15. So if I add 15 to both sides, I get 2x equals 16. So x equals 8. So again, here's our solution. That is elimination. Flip it over. So with example 4, it says, a movie theater sells tickets for $8 each, with seniors receiving a discount of $2. One evening, the theater sold 525 tickets, and it took in $3,580 in revenue. How many of each type of ticket was sold? Okay, so in order to do this, you need to know two questions. How much? And then the second question is, how many? The how much question says, how much is each ticket worth and how much did they make? So if we say we have X tickets for regular tickets and Y for seniors, then how many of them we sold was 525 of them. Now, a regular ticket costs $8, and then a senior discount ticket costs $6. And the total amount of money they made was $3,580. So now we have our system of equations. So from here you can do either substitution or elimination. I'm going to say, just for our sake, we're going to do elimination. So I'm going to multiply this first equation by negative 6. So I have negative 6x minus 6y equals 5. 5 times 6 is negative 3,125. I'm just going to check that on my calculator here. So again, I can do 6 times 525 equals 3150. Yes, 3150 50. So then 3580 plus a negative 3150, we get 430. So I have 2x equals, because these canceled, 430. So that means x, or the number of regular tickets I sold, is 430 divided by 2, or 215. If 215 regular tickets are sold, that means 215 plus our senior discounted ones equals 525. So 525 minus 215 says that y equals 310. I'm going to write senior, and this is regular. So that is solving and the types of story problems that we're going to get. All right, 2 more on this page. So example 5 and example 6 are going to look a little different because those other vocab terms that we talked about earlier are going to come up. So example 5, let's say we're going to solve this by elimination. So let's get rid of the y. We're going to multiply the top by -2. This should be familiar by now if this doesn't look like a review. So we have negative 4x minus 2y equals negative 10. And then I have 4x plus 2y equals 8. And if I add those two together, the x's cancel, the y's cancel, so I'm left with 0 on one side. And you have negative 10 equals 8, so you have negative 2. Now, if you look at this equation, you see that 0 equals negative 2. This is not true. That's not true. So, no solution. So the vocab word that we used at the beginning was inconsistent system, which means we have no solution. And graphically, that means that these two lines are parallel. So parallel lines give you a no solution or an inconsistent system. All right, last up. Let's try the same thing. So elimination, if it looks easy enough, these are both in standard form, so I'm going to multiply this by -3 to get rid of the y's. So I have negative 6x minus 3y equals negative 12, and I'm going to rewrite the second equation, negative 6x minus 3y equals, and I believe that's supposed to be, oh, I should have just multiplied by positive, and that's positive 12. So these cancel, and these cancel, and you're left with 0 equals 0. This is true, and so I'm going to put these 3 dots, which means, therefore, if you haven't seen that before, therefore, this is a dependent system, which also means infinitely many solutions. And what this means graphically is that we have one line, and then we're saying this line, this secondary line, is the exact same one. So where these intersect is at every single point on the line because they're the same thing. All right, flip it over. We're going to do one problem that's 3 equations and 3 unknowns, which takes a little bit of organization, and then we are done with level 11.1. With 3 equations and 3 unknowns, what's super important is to stay organized when you're solving these equations. So my advice to you is to number these equations because our whole goal is going to be getting rid of one variable from these 3. So if we look here, we can eliminate the x, the y, or the z first. I would suggest that we first get rid of the x variable because our numbers aren't going to get that big. So I'm going to combine 1 and 2, and that's going to give me my first equation. So what do I have to do for 1 and 2 to get rid of the x? Well, I'm going to multiply the top by -4. So it's going to be -4x minus 4y plus 4z equals 4. That's multiplying everything through by -4. And then the second one is 4x minus 3y plus 2z equals 16. And we're adding these together because we're getting rid of the x's. So we have negative 4 plus negative 3, which is negative 7y. 4z plus 2z is 6z equals 20. So this is my first new equation that only has y's and z's. So now I can either combine 1 and 3 or 2 and 3 to get rid of the x's. So what I'm going to do is I'm going to combine 1 and 3. So 1 and 3. And I'm going to multiply number 1 by negative 2x. Or sorry, by negative 2. So we have negative 2x minus 2y plus 2z equals 2. And our second equation, 2x minus 2y minus 3z equals 5. And if we add those two together, we get, the x's cancel, negative 4y minus z equals 7. So this equation, now we have a total of 5. These are our two new ones. I'm just going to write our number 5 equation right underneath here. So I have negative 4y minus z equals 7. Okay, so from here, now we're going to try and eliminate one more variable. So I can see that the z's are really easy to get rid of. All I have to do is multiply number 5 by 6. So that's what I'm going to do. I'm going to multiply this by 6. So I have negative 7y plus 6z equals 20. And then I have negative 4 times 6, which is negative 24y. 6 times negative z is negative 6z equals 42. 6 times 4. And now I can just add these up. So negative 7 and negative 24 is negative 31y. The z's cancel. 20 plus 42 is 62. Now if I divide both things by negative 31, I can solve for y, which is y equals 2. Now I have y. I'm going to work my way back. I can choose either 4 or 5 to solve for y. So I'm going to choose 5. So let's go to 5 here. And I have negative 4y minus z equals 7. So I'm going to plug in my y here. And I have negative 8 minus z equals 7. So I'm going to add 8. Negative z equals 15. So z equals negative 15. Now I can go back up to one of my first equations. So I'm just going to do number 1 to finish this off. I'm going to write at the top. So with 1 I have x plus 2 minus a negative 15 equals negative 1. So x 2 plus 15 is 17. So then x equals negative 18. So our solution for this problem of our 3 equations and 3 unknowns is x equals negative 18, y equals 2, z equals negative 15, or you can write that as an ordered triple. So not an ordered pair, but an ordered triple would be negative 18, comma 2, comma negative 15. All right. We have one more example so we can see this process once again. Again, pick a variable that you want to solve for easily, and then we're going to reduce the 3 equations down to 2. So in order to do that, I'm just going to look at this. The easiest variable to get rid of looks like x. So I'm going to get rid of x first. We have 1, 2, and 3. So I'm going to combine 1 and 2. So with 1 and 2, I don't have to change equation 1. But with 2, I'm going to multiply that by negative 2. So negative 2x minus 4y plus 2z equals negative 2 times negative 9 is 18. We add those together. The x's cancel. I get negative 3y plus z equals 16. So this is my equation 4. So I'm going to do one more time. I'm going to use 1 and 3. So if that looks familiar, it's the same process as I used above. So first equation stays the same, 2x plus y minus z equals negative 2. And then I'm going to multiply 3 by negative 2. So that gives you negative 2x, 3 times, negative 2, so that'd be 8y, and then minus 2z equals negative 2. We add those together, the x's cancel. We get 9y minus 3z equals negative 4. So now this is my equation 5. So I'm going to rewrite my two equations here. I have negative 3y plus z equals 16, and I have 9y minus 3z equals negative 4. So I'm going to get rid of my y, which means I'm going to multiply this by 3. So I get negative 9y plus 3z equals 48. And then my second one is 9y minus 3z equals negative 4. And if we add these two together, the y's cancel, the z's cancel, so we're left with 0 equals positive 44, which is not true. So then this system is inconsistent, which also means no solution. Whichever you prefer to write, that's what I'll take. So I know that this says homework day 1, day 2, that this is split up. Just because of the remaining time that we have, both of these should be 11.1 problems. All right, good luck.